Okay, Joshua, we were trying to talk about how to graph a polar graph. And so go in first and look in the textbook in that section just to get the idea. So you've got a type of graph that's called a limison, one that's called a rose curve, and one that's a lemniscate. Sometimes it just helps to see the kinds of things you'll get when you go to graph these. Okay. Then it sounded like you were okay doing this, getting the table. Okay. So here I just got started doing the table. And if I were doing the 1 minus 2 cosine theta, I usually take my theta, do cosine theta. Okay. Then I do the 2 times that. Then I do the 1 minus that column until I get this value. And it's this column right here. This column right here. This is your R. And so I'm going to put whatever the value is I have there, that's my R, together with the angle, which is my theta. So here's my R when my theta is pi over 6. This is my R when my theta is pi over 3. Okay? So be careful on that. Make sure you get the positives and negatives. You really just need the decimal so you know where to wind up plotting those. Okay? So let me snip that and see if I can get both the graph and the table to show up at the same screen. Okay, good. All right, let me see if I can stretch that out a little bit, stretch this out a little bit. Okay, so one of the things you want to notice is that on the graph paper I provided, I highlighted the key angles because that graph paper, these little spokes that you see really go 15, 30, 45, 60, 75, 90. So really your focus in my table is on the ones that are bolded. And so then you're just going to plot these. So you're just going to come in and you're going to wind up plotting that last column where I like to organize my ordered pairs. Now, one of the things that's kind of hard is this one, the numbers are pretty small that you're getting, like you only go out as big as 3, where your radii, your circles going out, the very beginning one is right there at 1. So what you might want to do is change the scale, but I'm going to leave it the way it is, but I just want you to realize that. So things are going to be kind of really close to the origin there. Okay. So I'm going to plot the point -1, 0. So to do that, I'm going to go where 0 is. Let me change the color, make sure I'm in a nice bright color. So here's where 0 is. I'm going to back up 1. So that would be -1, 0. Then I'm going to go to pi over 6. I'm plotting this. So I plotted that one. I'm going to plot the next one. At pi over 6, the R value is -0.73. So I'm going to go to pi over 6. I'm going to back up, and it's going to be less than, it's going to be like 3/4 of the way to a -1. Okay, then when I get to pi over 3, I should be right there at 0. So I'm going to be right there in the center. All right, so that's those. Now, when I'm at pi over 2, my R value was 1. Okay, so pi over 2, my R value was 1 because the cosine of pi over 2 is 0. 2 times that would be 0. And then 1 minus 0 would be 1. So I'm going to be right there. All right, then the next one I have is 2 pi over 3. When I'm at 2 pi over 3, I'm out at 2. So I'm going to go out to 2. And it's positive 2, so it's on the terminal side of that angle. Okay. All right, so if I start connecting, I'm going around like this so far. See how I'm just kind of connecting, starting with the 0 angle, then the pi over 6, then the pi over 3, and so on. All right, so what happens when I get to 5 pi over 6? That one has a positive 2.73, so I'm going to be out 2 and then 3/4 of the way to 3. Okay, and then when I get to pi, I'm all the way out at 3. So it's like I'm starting this picture. It's kind of going around like so. Okay, I'm going to do one more point, and then I think you can continue from there. So when I think about being at 7 pi over 6, the cosine of that is going to be negative square root of 3 over 2. 2 times that would be negative square root of 3. 1 minus the negative square root of 3 is going to be at 2.73. So I need to plot the point 2.73 and 7 pi over 6. So when I'm here at 7 pi over 6, I'm going to be at 1, 2, almost to 3, 3/4 of the way to 3. So that's kind of coming back in now a little bit. Okay. All right, this one's probably going to have an inner circle when you're finished. So it's coming around. Just keep following and plotting as you go. I'll do one more. So at 4 pi over 3, okay, my cosine value is going to be negative. It's going to be negative 1/2. Okay. When I do 2 times that, I've got negative 1. Can't get rid of that arrow easily. Then when I go and I do 1 minus that, it's 1 minus negative 1, which is going to be 2. So I have a 2 together with my, what is that, 4? Oh, 4 pi over 6. I should have written 2 pi over 3. It's the same thing, but I should have reduced it. Okay. 8. This one right here, this has a 6, or maybe not. It should be a 3 right there. 4 pi over 3. Okay. When I'm at 4 pi over 3, I have to plot 2. So I'll be back at just 2 when I'm at 4 pi over 3. So that's here. So I'm coming in a little bit, aren't I? Okay. So you keep going like that and see what happens. Excuse me. All right. So plot those points, okay, just wherever they are, just like you do when we talked about how to plot the points on the first page of the polar packet. And then I just usually start at 0 and I go down the table and I plot the points as I go. And then it helps to know the gist of what you'll see. So let me blow this up a little bit. Okay. Get rid of that guy. Okay, so the 3 curves can turn out to be what's called a limnoscale, limison. So those sometimes have like a little inner circle, and it can be oriented that way or sideways, or sometimes they just kind of do like that. Okay, kind of come around like that. They have interesting things they do, and sometimes they're not even that dented. Sometimes they're kind of flattened, not quite a circle, kind of flattened there. That's one type. Another type you get sometimes are called a rose curve. They'll look something like this a lot of times, or maybe just have 3 petals equally spaced. Okay, and they're usually equal. That's a rose curve. This is a limison. Okay. And then another one you can have is called a lemniscate, and it kind of looks like a rose curve, but it's almost just like an infinity symbol, but it can be in an interesting orientation. That's called a lemniscate. And so you'll see those in that section, and I think that'll help you if you kind of know the gist of what they turn out looking like, because they don't look like the graphs that you do in a pre-calculus class, because you're not working in the rectangular coordinate system. Okay, they look more like a spirograph picture. All right, so I'm going to stop sharing and send that to you and see if that helps you be able to finish those up, because it'd really be nice to check those off your list.